So now that we've had some practice at graphing the solution sets to systems of linear inequalities, let's talk about reasonable solutions. So identifying reasonable points that make the inequality true. That's what a solution is, and that's what we're going to add to our note card. So solution is, we don't need to put that. A solution is a coordinate pair in the solution. Well, it's a coordinate pair in the graph that makes both inequalities true, and that's really important when we're talking about solutions anytime, is that it's when it makes mathematical statements true. That's what an inequality is. It's in a mathematical statement, like an expression or an equation. Those are all mathematical statements. So for each of the graphs that you did in this practice, the next thing that I want you to do, and we're going to add this to the instructions, is to identify 3 solutions and 4 non-solutions. And I'll talk about why with this first example. I want to give you an opportunity to show me you can, and to show yourself that you can identify multiple different kinds of non-solutions, because there's a bigger variety of non-solutions than there are of solutions. So obviously, where are solutions, right? Well, the solutions, and let's do those in gold, right? Let's look at the solutions, because it's where the shaded part intersects, right? That's where the shaded part intersects. These are examples of solutions. So this one is 2, 4, 2 and 4. The one right under it is 2 and 2, and this is 4 and 2. Okay, so those would be examples of solutions. Solutions. 2, 4, 2, 2, and 4, 2. But then we look at different kinds of non-solutions, because I see lots of different kinds of non-solutions. I see a non-solution right here. I see a non-solution here. I see a non-solution at this point here, and I see non-solutions out here, obviously. Right, there's no shading out at -3, +1. This is a non-solution. But there's no shading out there, so obviously that's not a solution, non-solutions. But then we've got some interesting examples, right? We've got one on the solid line, the y-intercept for our second, or our first polynomial. No, our first inequality, 0, -1. So we see that, and so I want you to answer why this isn't a solution down beneath here. And then for each of these, right, let's talk about why these aren't solutions, because this 2, -2, that's shaded. 2, -2, 2, -2, that's in a shaded area, but why isn't that a solution? So talk about that. And then you can answer those right down here. And then this one on the dotted line, and it's kind of in the intersection of the shading on that boundary line, but I don't think it's a solution, and it's a 0. right? This is the zero of that boundary line. So it's the y-intercept, but that's not a solution either. And so answer why those aren't solutions right down beneath those points where that arrow is. And we can look down at this other example. Do I have another example? Yeah, we can look down here in this other example, right? I definitely think that this is a solution, and I think this one is too, and that one. But here, not that color, these points, I do not believe are solutions. So, right down beneath, identify the given solutions and non-solutions, right? The different solutions and non-solutions, and then describe why these aren't solutions. And then you do the rest of the practice problems for each of these, identifying 3 solutions and 4 non-solutions. 3 solutions and 4 non-solutions.